Today we're going to talk about complex numbers. A complex number is any number that can be written in the form a plus bi, where a and b are real numbers and I is our imaginary unit, which is the square root of -1. For a complex number, a is called the real part of the number and b is the imaginary part. So when I look at this box here, I see a number of different things. 3 plus 4i is a complex number, which makes sense because it follows that same format, a plus bi. Well, in this case, 3 plus 4i. 3 is the real part, 4i is our imaginary part. 4 minus 2i, again, fits that a plus bi, just with a minus sign between them. And then 1 minus I times the square root of 5. But interestingly enough, all real numbers and all imaginary numbers, though completely separate from one another, are also part of the umbrella of complex numbers. Because if you think of the number 17, for example, 17 can be rewritten as 17 plus 0i. -5 can be written as -5 plus 0i, and therefore would fit the same format of that a plus bi. Same with imaginary numbers. 2i can be written as 0 for the real part, plus 2i, and -7i can be written as 0 minus 7i. So we can do a number of different operations with these complex numbers, similar to ones that we can do with real numbers and imaginary numbers. Let's start with adding, subtracting, and then do some multiplication as well. In this first example, I've got 3 minus I, and I'm going to add to this 2 plus 3i. How I do this is I'm going to stack them one on top of the other, putting the real numbers in a column and putting the imaginary numbers in a column. So I've got 3 minus I like so, and I'll put 2 plus 3i just below it. Since I'm adding these, I'm going to put a big plus sign to the left, and this will give me 5, and then -I plus 3i is plus 2i. Here I've got 3 complex numbers, 3 plus 2i, 4 minus I, and 7 plus I. I'm going to be adding the first two and then subtracting the third, but I still follow the same kind of format here. I'm going to stack them all on top of each other, put my operations, and see what I get. So for this, I'll do 3 plus 2i here. 4 minus I will go here. And then 7 plus I will go here. Now for my operations, I'm adding the second one, and I'm subtracting the third one. Now I can go straight down, keeping in mind to always do our operation that's to the left. 3 plus 4 is going to make 7. 7 minus 7 will be 0. So I've got 0 here. 2i plus -I, that's going to take out an I, just being a single I, and then subtract another I. That's going to be 0 plus 0i, or just 0. What about multiplying, though? So for multiplying, I can either use the FOIL method or I can use the box method. Here I've got some distribution that's going to take place, but no matter what I do, I have to remember that I squared is equal to -1. That comes from I being the square root of -1. So if I square both sides here, like so, we'll see I squared is equal to the square root of -1 squared, but the square root and the square will undo each other, leaving just I squared is equal to -1. Okay, so for this example, I've got a 5 on the outside of this quantity -2 plus 3i. I'm going to distribute this 5. And that'll give me 5 times -2 is -10. And then 5 times 3i, it will be 15i. So this will be negative 10 plus 15i. But for ones like example D, I've got two binomials that are multiplied together. Whenever that takes place, I have to use one of these that I mentioned earlier, either FOIL or the box method. So let's do the box. I'm going to set up a box like so. Along the top, I'm going to write one of my binomials. So let's do 2 minus I up there. Down the side, I'm going to write the other one, 4 plus 3i. And then for each of these cells, I'm going to multiply to what is showing on the outside for the column or row. So what I mean by that is here, this will be 2 times 4, that makes 8. For this one, this will be negative I times 4, so negative 4i. For this one, this will be 2 times 3i, so 6i. And lastly, 3i times negative I, that's going to make negative 3i squared. However, since I squared is negative 1, this is really saying negative 3 times negative 1, or just positive 3. Now that I've got all this, I can just combine like terms. 8 plus 3 will give me 11. And 6i plus negative 4i will give me 2i. Let's do another one like that. Here in example E, I've got 3 plus 2i times 3 minus 2i. So just like example D, I'm going to set up another box. I'll put 3 plus 2i along the top, and 3 minus 2i along the side. Okay, 3 times 3 will make 9. 3 times 2i is going to make 6i. 3 times negative 2i is going to make negative 6i. And then negative 2i times 2i, this is going to make negative 4i squared. Again, because I squared is negative 1, though, this is really saying negative 4 times negative 1, which will be a positive 4. I can combine like terms. 9 plus 4 is going to make 13. And then interestingly enough, 6i and negative 6i, those are going to subtract out, meaning that I've got 0i, or I can just write this as 13 by itself. Okay, so what happened here? I added and subtracted some complex numbers, and I saw that I could get a complex number back, or I could get a real number back, which is just 0. I also multiplied some complex numbers, and I saw that the result could be a complex number again, or it could be this real number, in this case for E, 13. Well, notice in the last example, the product of these two complex numbers is real, and this is because these are complex conjugates. 3 plus 2i, 3 minus 2i. Essentially, conjugates are binomials with the same first terms and opposite last terms. So we'll see a 3 here and a 3 here. We'll see a 2i here and a 2i here. Only one of them is going to be positive and the other one will be negative. Whenever I multiply two conjugates together, two complex conjugates together, I will always get a real number answer. So you might get some problems that look like this. Multiply each number by its complex conjugate. Well, if I'm given 1 plus I, really this is asking you to multiply by 1 minus I. So let's see what that gives us. One plus I, and then 1 minus I down the side. This will be 1. 1 times I, or just I here. 1 times negative I is going to make negative I here. And then I times negative I is going to make negative I squared. Again, because I squared is negative 1, this is essentially saying negative 1, or double negative will make a positive. This is positive 1. Combining like terms, 1 plus 1, that's going to make 2. And then we see here that the I and the negative I are going to undo each other, leaving this just as 2. Let's do one more. 4 minus 3i. The conjugate of this would be 4 plus 3i. So this is asking you to multiply by 4 plus 3i. Let's make a box and see what we get. Okay, along the top, I'll do 4 minus 3i. And down the side, I'll do 4 plus 3i. Here, 4 times 4 will give me 16. 4 times negative 3i, this is going to be negative 12i. 4 times 3i, this is going to be positive 12i. And then finally, 3i times negative 3i is going to be negative 9i squared. Of course, I squared being negative 1. This is negative 9 times negative 1. So this will be a positive 9. Combining like terms, 16 and 9 will give me 25. And negative 12i and positive 12i, those will subtract out, going to 0. All right, so we talked about adding, subtracting, and we just did multiplication. What about division? Well, as it turns out, instead of dividing complex numbers, you can equivalently multiply the numerator and denominator by the complex conjugate of the denominator, and it ends up being the same thing. This is actually a lot easier to do than trying to do actual division with these complex numbers. So as an example, let's say I've got h here, 2 plus 3i, this is over 4 minus 2i. What I'm going to do with this is I'm going to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of 4 minus 2i is going to be 4 plus 2i. So this means that I've actually got two of these box problems in one. The top part is going to be 2 plus 3i times 4 plus 2i, and the bottom part is going to be these complex conjugates multiplied together, 4 minus 2i times 4 plus 2i. Let's do the top part over here, and then we'll do the bottom part to the right. Okay, so for the top part, I've got 2 plus 3i. And then I'm multiplying to that 4 plus 2i. Okay, this is 4 times 2 is 8. 4 times 3i will give me 12i. 2i times 2 is going to be 4i. And then 2i times 3i, 2 times 3 is 6, and then I squared. Again, because I squared is -1, this is 6 times -1, so this will just be -6. Okay, so the top part, 8 plus -6 is going to be 2. And then 4i plus 12i, that's going to give me 16i. Now let's figure out the bottom part. 4 minus 2i times 4 plus 2i. We'll make another box. Along the top, we'll do 4 minus 2i. And down the side, 4 plus 2i. 4 times 4, this will make 16. 4 times -2i, this will be -8i. 4 times 2i is going to be a +8i. And then 2i times -2i, this will be -4i squared. Again, I squared is -1, so this is -4 times -1, giving +4. Combine like terms. 16 and 4 will make 20. And then -8i and +8i, those will subtract out, leaving just 20 here. So let's put the top part over the bottom now. 2 plus 16i over 20. And I noticed that both 2 and 16 are even on the top and 20 is even on the bottom. Everything is divisible by 2. So let's reduce this to 1 plus 8i over 10. If you wanted, you could also split this up. Make this 1/10 plus 8i over 10, and then you could reduce that further. This would be the same thing, so I'll say or. You could say that this is 1/10 plus, and then instead of 8i over 10, you could say that that's 4i over 5. Both of these would be acceptable. Okay, a couple more things. Complex solutions of quadratic equations. So what we're going to do here is we're going to multiply some of these square roots together. We'll subtract some square roots, do some of these different operations, and see how these will simplify. In this first one, I've got the square root of -3 times the square root of -12. Well, we know from an earlier section that I can break these down and say that this square root of -3 is really I times the square root of 3, and I'm multiplying to this I times the square root of 12. Well, now, let's say I times this I, it will be I squared, times the square root of 3 times 12 will make 36. I squared is -1. And the square root of 36 is just 6, meaning that this, -1 times 6, is -6. And there's a number of different ways that you could go about simplifying this. This is just one of those ways. It doesn't necessarily mean that this is the best way or the quickest or most efficient way, but all of these will get you to the same answer. All right, let's try this next one. J, the square root of negative 48 minus the square root of negative 27. All right, well, let's see. Let's start by saying that the square root of negative 48 is the same as saying I times the square root of 48. And I am subtracting I times the square root of 27. Okay, well, let's see if we can break up this 48. I know that 48 is divisible by 4. 48 divided by 4 would give me 12. Let's see if I can go further than that. 48 divided by, let's go the other way, 12. Oh no, 16. 48 divided by 16. That's an even better one. This would be I times the square root of 16 times the square root of 3 then. Okay, what about over here? I times the square root of 27. This will be I times 27. I can break up and say 9 times 3. So this will be the square root of 9 times the square root of 3. Now, the reason I might do it this way is, well, there's a couple of reasons. One, I can actually take the square root of 16. That's a perfect square. I can actually take the square root of 9. That's a perfect square. And what I'm left with is a square root of 3 here and a square root of 3 here. So let's see what this gives us. The square root of 16 is 4. So this is 4i times the square root of 3. And I'm subtracting 3i square root of 3. Well, if I've got 4i times the square root of 3, and I'm subtracting 3i times the square root of 3, then what I'm left with is a single I times the square root of 3. Okay, what about this? Negative 1 plus the square root of negative 3, this whole thing squared. Okay, so this is really saying negative 1 plus the square root of negative 3 times itself, so another negative 1 plus the square root of negative 3. Let's see what this gives us. I'm going to make a box here. Negative 1 plus the square root of negative 3, and negative 1 plus the square root of negative 3. So negative 1 times negative 1 is going to make a positive 1. This is going to be minus the square root of negative 3. And then I've got another minus the square root of negative 3. And here, the square root of negative 3 times the square root of negative 3, this is the same as saying the square root of negative 3 squared. The square root and the square will undo each other, leaving just negative 3. Okay, combine like terms. 1 plus negative 3, that'll make negative 2, minus 2 times, I've got 2 of these square roots of negative 3's. Last thing here, I can just take out the negative 1 and say this is the square root of negative 1 times the square root of 3. So this is negative 2 minus 2i square root of 3. We've got one more thing to do here. And that's solving using the quadratic formula. The quadratic formula, you may recall, is the following. X equals negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. And what this is doing is taking this quadratic equation, making sure it's set equal to 0, and your coefficient on your x squared is your a. So in this case, a equals 3. B is your coefficient on x, so b equals -2. And then c is this constant, c equals 5. And these values are going to get plugged into the quadratic formula to find a solution. So let's write that again. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You may also recall from an earlier class that the part under the square root, b squared minus 4ac, this is the determinant. And the determinant helps us, well, determine whether we're going to have real solutions or imaginary or complex solutions. And how this happens is I just plug in for the determinant, and if it's positive, I'll have 2 real solutions. If it's exactly 0, I'll have 1 real solution. And if this is negative, I know that I'm going to have 2 non-real solutions. So let's plug that in over here. B squared minus 4ac. For us, this is going to be -2 squared minus 4 times a is 3 and c is 5. -2 squared is going to make 4 minus 4 times 3 times 5 is going to be 60. So this will be 4 minus 60 is -56. From here, I know that I've got 2 non-real solutions. What does that mean? It means that my answer, x equals, is going to have a plus or a minus in it, because it needs 2 solutions. And because these are non-real, I know that my final result should have an I somewhere. So let's plug stuff in. X equals -b. Since b is -2, this will be -2, or just +2, plus or minus the square root. Now we've already plugged in the determinant. This is -56, so I'm just going to plug that in right here. And this is over 2 times a is 3, so 2 times 3 is 6. All right, x equals 2 plus or minus. Let's break up this -56. This is the same as saying the square root of -1 times the square root of, let's see, 56 is divisible by 4. And I'll be left with the square root of 14 is left over. All right, this is all over 6. X equals 2 plus or minus, let's do the square root of 4 first. That'll be 2. The square root of -1 is my imaginary unit, I. And then square root of 14 is left over 6. And I can simplify this. X equals, these are all even, so I'm going to divide these by 2. This will be 1 plus or minus I square root of 14 over 3. Okay, hopefully this video gives you an idea of the different things that we can do with complex numbers and the different operations that can be done just like real numbers and imaginary numbers.